Networks from the dark side. Wing, wing, wing. By the time we're done here, we will learn specific network values that could sabotage your calculations and how to avoid going down that road. Well, if I'm feeling you correctly right now, which I think I am, you've seen 3 different examples of subnetting: Class C, Class B, Class A, if you've gone through the skill in order, and you're feeling pretty good about it. You're like, I think I got this. I still need to practice it, and we're going to do that in the next nugget. But you're like, yeah, I think I got at least the premise of the whole thing. And that makes it the perfect time to show you a little bit on how this works and how you could step into trouble if you're not aware of it. So first and foremost, you're feeling pretty good about how the whole idea of this, right? We have our binary chart: 128, 64, 32, 16, 8, 4, 2, 1. We know how computers calculate numbers, at least up to 8 bits, and even beyond 8 bits, 1 byte of information, right? So the whole secret sauce behind this subnetting method is you take how many values you need, how many networks you need, and you say, okay, well, how many binary bits does that require? And then you just reserve that in the mask. You block those out so that they can be reserved and you can get that number of networks, right? And that's what I think you've got. You're like, oh, okay, I kind of see how that works. Well, you run into trouble when you hit specific values, and it's simply because binary counts from 0. And I know you've run into this before where it's, I don't know, I can't even think of something right now, but you'll be talking to a friend or something, or figuring something out, and voltage or something. And you're like, okay, so it's going to be 60, right? And then you're like, no, hang on. 0 counts. So it's 61. So hang on. Yeah, it's going to be 60, right? You ever run into that and you're trying to describe that and they're like, what? No, it's 60. Well, no, you count from 0. Well, it's the same thing when you come to this. Let me give you a perfect example of how this works. So let's just say 192.168.1.0, right? I say, there's your network, and I want you to break that into 2 networks. Now, the non-informed person would look and they would go, oh, okay, well, convert that number to binary. So, okay, first one goes right there. So it takes 2 bits to get the number 2. Actually, no. I know. You're looking, you're like, yeah, because it's right there. Well, remember what binary is. Binary is a 0 and a 1. That's a bit. Everything in binary is a 0 or a 1. And if you look at 1 bit, 0 and 1, that's how many values? I know. I know you're like, hang on. It's 2, right? It's a 0 and it's a 1. It's the same thing. Like if I were to say 4, right? And you're like, well, if 1 goes right there. Well, actually, you can get the number 4, or you could get, let me say it this way. You could get 4 values. You can't get the decimal number 4, but you could get 4 values with 2 bits. Well, how? Well, 0, 0, 0, 1, 1, 0, 1, 1, right? This in decimal is 0, 1, 2, 3. So in decimal, we only get to 3, but we actually get 4 values. And that's the stumbling point. That's where you can run into problems with this, is because you can look and go, okay, well, 64, and it's coming because somebody's like, I want you to figure out 64 networks. And you're like, that seems like a really weird number. Why would you want 64? Or, I want exactly 32 subnets. You're like, why would you want that? Well, the reason why is because they're like, I'm trying to throw you off on one of these exceptions. Instead of putting the 1, you can actually get 32 values by using, 5 bits. Anything that lands right on that binary value is right. And let me make sure I can prove it to you. You remember that formula I gave you? 2 to the power of stuff. I said X, but stuff, stuff being how many network bits or how many hosts. So I said, where this came from is I said, if you want to know how many networks do you really get, how many subnets do you really get, or how many hosts do you really have per network, you can use the formula of 2 to the power of stuff, where stuff is the number of network bits that you're using or the number of host bits, right? Well, look at this. If I said, how many networks do I get if I do 2 to the power of 1 bit, right? And you can say that without even looking at it. You're like, 2, right? 2 to the power of 1 is 2. So I can actually get those 2 networks. So what do we do with this? Well, there's a couple things. Now that you know, it's kind of like, now you know. It's like it's like a public service. Now you know. Knowing is half the battle. G.I. Joe. Something like so. And you just will recognize it in the future because now that you know, it's easy to recognize. The other way is to introduce just a rule. You could always just say, no matter what, when somebody says, 30 networks, I will always subtract 1. If somebody says 2 networks, I will always subtract 1. If somebody says 100,000 networks, I will always subtract 1, because you will never get the wrong answer if you subtract 1. It's just, again, if it lands on one of those binary equivalents, you could end up over provisioning the system instead of, hitting it right on. And someone once told me when I showed them this, they go, well, how come you didn't tell us to just figure out the number of networks based on this? Like, how many networks do you need? Well, just use powers of 2 to do it. Truth be told, when I first developed this method of subnetting, I did. I was like, that'll be 100% accurate every single time. And what I found is the barrier to learn subnetting was so much greater, because instead of doing something logical like, hey, you need how many networks, let's convert that number to binary, and that tells you how many bits you need, you're starting off with like, okay, we're pulling out 2 to the power of stuff, and let me explain what, and people were just like, what? Like that's where people are just like, it would take so much longer to actually, you would end up with so many more errors going that way than they're just showing like, look, this is how it makes sense. It's just the fact that we start counting from 0 that gives us that extra value every single time. So what I do, I recognize it. Okay, it's a binary boundary, right? It's the 8 values, what they are: 128, 256, 512, 1024, 2048. You just those values should stand out in your mind. And the more that you do subnetting, the more you're like, they're trying to catch me. So that's it. You've now seen those specific troublesome values that could lead you down a wrong road, and you now recognize how to avoid them. I hope this has been informative for you, and I'd like to thank you for viewing.